Hello YouTube viewers, welcome back to my channel. 3 tips here, part 4 of the silver cell anode filter recovery and refining series. And what I've got to show you today is some very interesting things. I've got some solutions out there that I'm not used to working with. This is the first time I've encountered the solutions in this mix. I've got silver, platinum group metals, and I think a little bit of gold in solution all at the same time, and I've never really worked with that. So we're gonna go out and do some tests and see how we can proceed with getting the rest of the metals out of these solutions. Here we go. I'm gonna start out with a little review here. I've got some solids that I dissolved in nitric back here in this beaker. I'm gonna filter that out and then extract the palladium with DMG. This is the beaker that I had already filtered the solids out of it, and then we added DMG and got the DMG out of there into a filter. That's what's in this beaker right here. And we're going to process that later on. After we get the palladium out of here, I'll add the palladium that we precipitate out of this solution in here, and then we'll work with these solids. I just want to show you in this beaker here, I've got some kind of precipitate that's come out of solution there and fallen to the bottom. I'm not sure what that is, but we'll take a look at that. We're going to have to filter this solution one more time. And then over here is my nitric solution. It's got gold in it. I took a small sample here, put some DMG in there just to see what that would do, and I got a little nugget that precipitated out. I think it's gold. And then over here I took a small sample of this solution, added some DMG to it, and I've got some precipitate in there. Not sure what that is. We'll get that out of there and take a look at that. I'll start this off by testing my testing solution. This is my stannous chloride testing solution. I made it 13 February. This is April. What I'm going to do here is I've got 3 standard testing solutions over here in this beaker. And I made these by dissolving 1/10 of 1 gram of gold in 100 ml of solution. We'll drop it out on our filter or our paper down here. Next I've got same thing, but it's platinum. 1/10 of 1 gram dissolved in 100 ml of solution. We'll drop it out on our paper. And then I got I'm going to put a drop of palladium standard testing solution, 100 milligrams or 1/10 of a gram, dissolved in 100 milliliters of water. Drop it out on our paper here. Now we're going to take our stannous chloride testing solution and put some drops of it on each of these spots that I put on this piece of paper towel here. Make sure our stannous chloride testing solution is working properly. That's the gold. That's the platinum. And that is the palladium. You'll notice here that each of these little dots that I put on this paper towel all look different in color. This is the palladium. It's got a brown stain with green in it. This is the platinum. It turns orange when it comes in contact with the stannous chloride testing solution. And this is our gold. It turns purple. I've laid out 2 pieces of filter paper here. What I'm going to do is I'm going to reach into our big beaker here, get a little bit of this solution in a pipette, and I'm going to apply a drop of it to this filter paper here. Next, I have a silver nitrate solution that I've prepared, 200 grams per liter. What we're going to do is reach in here and get a little bit of this in a pipette and put that on our test strip here. Now I'm going to take some stannous chloride testing solution, put it on each of these test strips over here, see what happens. First our silver nitrate solution, and then the solution out of our beaker. Since I applied the test solution to these strips. This is my silver nitrate solution that I prepared, and this is the beaker. Got a larger pipette here. I'll reach down into our solution and get a little bit of this up into our pipette. I'm going to transfer it into this beaker here. I can do it without making a mess. Bit of hydrochloric acid to this beaker here. It's about 40 milliliters. Now what we'll do is I'm going to slowly add hydrochloric acid to our solution in this beaker here. We're going to try to precipitate the silver chloride out of it. Stir this up a little bit. What I'll do is just adding the hydrochloric acid until no more precipitate forms here. That's silver chloride forming in there. As long as I add hydrochloric acid and get a reaction like that, that means we still have silver chloride in solution. I'm trying to determine what metals are in solution in that large green beaker there to the left. But before I can use stannous chloride testing solution to check and see what metals are in that solution, I have to remove the silver first with that hydrochloric acid, because as you can see by the two tests that I did on those test strips, stannous chloride will react with the silver, and that will cover up or mask any indications that I might get from other precious metals in that solution. Add a little bit of water to this. Now let's put some more hydrochloric acid in. Still getting a reaction, and I'm not. See how the silver chloride stopped forming now? It just makes a yellow colored liquid down there when I put the hydrochloric acid in. So it took about 10 milliliters of hydrochloric acid to get all the silver to precipitate out of here. These two tests down here look like I have platinum group metals in solution in here and in here. But I know for a fact this is pure silver nitrate solution, but it looks like we've got other metals in solution. Here's my point. I did not know that stannous chloride will react with silver in solution and give a reaction like we're seeing on this piece of filter paper. In my hand I have two fresh pieces of filter paper. This is some of the solution out of the beaker up here. I'm going to put it on this piece of filter paper here. And now we're going to take this other piece of filter paper, put it down in our beaker here, get some of that solution on there. I just dropped the silver out of here. This solution came from this beaker. So now I'm going to put stannous chloride on both of these. And we're going to take a look and see what kind of reaction we get on both of these pieces of filter paper. Adding hydrochloric acid to that silver nitrate solution will drop the silver out, and the hydrochloric acid should not remove any gold or platinum group metals that are in that solution. They should remain in solution and be detectable on a stannous chloride test. And as you can plainly see on that small piece of filter paper there on the right in my fingers, there's no reaction. So that tells me that there's no gold and no platinum group metals in that solution. Okay, as you can plainly see, the solution in this beaker has no metals in it. No silver, no platinum group metals, nothing. You get no test or reaction with the stannous chloride. This gave us a reaction. This came out of this beaker right here, and it gave us a reaction. So what I'm concluding here is, and I didn't know this until just today when I did these tests, the stannous chloride will indicate silver in solution on a piece of filter paper. If I had metals in this solution, after I took the silver out with the hydrochloric acid, like I did in this beaker right here, made silver chloride, the platinum group metals or gold, whichever the case may be, that I thought was in this solution, would show up on this piece of test strip, and it did not. This solution is void. Okay, this really isn't part of my refining video, but I wanted to show this, include it in the footage. What I've got is a couple pieces of jewelry here that my wife wants to keep, and so I sterilize everything by putting it in hot water in my ultrasonic cleaner over there. This is some earring backs that I'm going to be giving to my daughter. She lost some earring backs off of her earrings, so I've got a couple of those and I wanted to sterilize those for her. So now we're going to take this stuff out. Now that I've got it cleaned off in the ultrasonic, I'm going to take this out and hit it with the steam cleaner right quick. This is a solution. Looks like it's got a little rat turd in it down there that came from this bottle right here, which is nitric acid that has gold dissolved in it. And I put some DMG in that solution to see what would happen, and I got that little piece of gold that came out of solution. Now what I'm going to do, this is nitric acid in here. I'm pour this solution off. Rinse it out a little bit here. And then what we'll do is reach down in there. I'm going to get some hydrochloric acid. Put it in there with it. Hydrochloric acid. About a 1.5 ml. I'm going to put a couple of drops of turn the camera off, and I went to get some nitric acid to put in there. That little thing already went in solution. Didn't catch it on the camera. That whole thing went into solution. I'll put a little drop of nitric in there just to make sure. Let's drink nitric acid. I'm not catching some of these things on video because I'm a little bit off kilter here. I've got professional people watching. I've got some chemists watching. I know that. I can tell by their comments. And I've got some professional refiners watching me, man. It's kind of unnerving because I'm just a hobbyist here, man. I'm not a professional chemist or refiner. What we're doing here is trying to see if we've got gold in solution. And judging by that stain, it looks like we do. It looks purple. And what that does is that verifies and lets me know that that was in fact gold in solution that came out of our nitric solution. I had added some DMG to this. Took a little bit of this out, put it here, put DMG in it, and that little rat turd came out of the solution, which was gold. And my conclusion there is that dimethylglycine will precipitate gold out of solution. There's the proof right here. It's gold. And this is a little bit of the solution out of our big beaker over here. I added DMG to see if I had all the palladium precipitated out, and I ended up getting a black precipitate in here. I've already proven that the DMG will drop the gold out of solution, so I'm just going to conclude that after adding the DMG to this solution, that's what I've got is gold. I'm going to pour it in here so we get our vacuum built up, and it should just that little black stuff on the filter there should be gold. And now what we're going to do, I think I got some gold that precipitated out of our big beaker here. We're going to pour this through the filter now. Filter this solution one more time and try to get the gold out of here. I'm going to try to sum up what I think has happened here. I had this silver solution that had platinum group metals in it. I extracted the palladium and platinum with dimethylglycine, and I immediately removed this precipitate out of the silver solution. There was residual DMG, dimethylglycine, left in the silver solution, and there was some gold in this solution from the nitric acid boils. I proved that nitric boiling can put gold in solution. I've got a bottle of it right here. So when I did the nitric boils, I put some gold in solution. After I got the palladium out with the DMG and filtered it out. The solution was crystal clear. I allowed it to set overnight. And when I came out in the morning, there was some precipitate down in here. And I concluded that, based on this test over here with the little rat turd, that the precipitate down in the bottom of this beaker is the gold that the DMG precipitated out. I hope that's a good enough explanation there. I don't know if that's exactly what happened or not. This solution is foreign to me. It's the first time I've worked with a solution with all three of those metals in solution, and I'm kind of out of my experience zone here. I've got just about this entire solution through the filter here now. And so what we're going to do is get these solids to a separate filter over here. This pulled through the filter now. Gonna rinse this out real good, and the more I look at this, the more it looks like gold, metallic gold that precipitated out of the solution with DMG. That's amazing. Got everything pulled through the filter here, and this looks like gold to me. Gold that precipitated out of our main solution that was mainly silver with DMG. I keep saying that, I know, but I'm amazed by it. I've never seen that happen. If you look at this, in the bottom of this beaker, this is definitely gold. See, the gold did not precipitate out right away. It sat here for a day. I didn't work on this for a day, and it sat here. And by sitting, the gold slowly over time precipitated out. That's important to know, because we don't want the gold precipitating at exactly the same time that the platinum group metals do. Oh, another thing, I switched over here to a gravity filter because I want to collect the gold in this filter, because I'm going to melt it into a button. And if I'd have put it over here in this filter, a lot of the solid gold particles would have adhered to the inside of the filter. So that's why I chose not to use the Buckner funnel to gather all the gold. That's why I switched to a gravity filter, because I know I can control the amount of gold that gets past the filter. Nothing will in this. If I use this, some of the gold can get past the filter and collect on the inside of the Buckner funnel. I can still get it out of there, but why mess around with that when I can just pour it through a gravity filter and collect 100% of the material in the filter here. That's a respectable amount of stuff in here. It looks like gold. It's acting like gold. Rinse it right quick with some distilled water here. Now I'll remove the filter here. get it out of the way. I've got some copper, pieces of copper. I'm going to add these to my beaker. And then we're going to go straight silver nitrate solution here. No additional water like I like to do usually. I'm going to pour the silver nitrate solution right in and start cementing the silver out on this copper. The silver cementing out in here. I'm getting a little bit of fume production. That means I had excess nitric in here. That will needlessly consume my copper. That's okay. What I'm going to do is reach back here, get our funnel. It's got a little bit of gold in the filter paper. Take this out. Put this on our melt dish. I'm going to get the gold out of this funnel. It's got quite a bit in it. I'm going to get this out now. Put this down in our melt dish here. Got that gold in this melt dish. I'm going to put it on the melt table here. I'm going to cover this up with borax, and then we're going to light the flame and melt this gold. I add that borax to act as a flux, and what it does is kind of helps that paper stay glued into the melt dish. As I do the melt, the paper will burn away completely and leave no traces of paper in the melt dish once we get done here. And you can see all that's left is a little gold bead down in the bottom of the melt dish. It's going to be low purity. There's going to be other metals mixed in with it, possibly some platinum group metals and definitely some silver. But that's a nice little bead of gold, and we'll be able to refine it further in a future video. Here's our little bead of gold. I've tested it. It's got a silver appearance to it, but down underneath where I filed it, it's yellow. So I'm going to call it, it's probably 20 karat gold, 18 karat gold. I'll throw this in with my next batch of carat scrap. So we got 1 gram, 1.1 grams of 18K gold out of our silver cell anode filters. The silver is cementing out in this beaker here. If you notice, I've got some fume production going on. That means we've got excess nitric acid in this solution. This is a perfect example of why we want to consume all of the excess nitric before we go to cement the silver out of our solution. What's going to happen is, because we have excess nitric in here, it's heating up. Because we have excess nitric in here, I'm going to needlessly consume the copper. If I remove all that nitric, before I start cementing on copper, then I don't consume my copper like I'm going to be doing here. I'm going to go ahead and add this solution that we poured off to the beaker so that we've got everything cementing out now in this 5-liter beaker. We'll get our silver out of the stuff that we've already dissolved and filtered and extracted the palladium from, and the gold. This is our silver that's been cemented out on copper. It's been allowed to react overnight. As you can see in there, it is full of silver. There's still a few pieces of copper in here. There's one right there. So I'm just going to leave this continue to react so we get all the metals out of solution in here. Notice it's still green, which is an indication that there's probably something above copper in the reactivity series of metals in solution with the silver, such as maybe iron. There might be some iron in here, or it might be nickel. I don't know. Either way, we've cemented out the precious metals below copper, mostly silver. Now, before I can proceed, I've got two solutions over here. What we're going to do is, these solutions have had all the silver cemented out of them. What I need to do now is empty these blue solutions up here into my waste treatment bucket that's full of angle iron. What will happen in there is the copper will cement out of these blue solutions onto the iron. Here we go. I'm going to siphon this solution out of here right now. Try to get the camera right for you. Look down here, this is my copper solution that I just siphoned off into my bucket full of iron. I'll set this under the fume hood because it will produce some gas. I've got a lid here with a little hole cut at the top. And what I do is I've got an air bubbler and I stick that in that hole in the top and bubble air through this solution to create some movement in there. And now this solution here, this is waste. This is the iron in solution. And what we'll do to treat this is I take it outside because it makes ammonia gas. I add sodium hydroxide to that and precipitate out the iron as iron hydroxide. This will conclude part 4 of the series. I was able to extract a little bit of metal out of that silver solution. It is in fact gold. It's low carat gold, probably contaminated with some silver and some platinum group metals. But it weighs about 1 gram. And I'm just thankful to get a little bit of metal out of those filters so far. But I didn't even get a chance to touch the second half that I dissolved in nitric acid. So that'll be coming up in the next video. At least I got the silver cementing out on copper now. And we got the first extraction of palladium, and that's ready to be processed. So in part 5, what we'll do is we'll get the rest of the metals out of that beaker that I've got sitting in the back there that I extracted with hot dilute nitric acid. And just a few comments here. Thanks again to the folks who have made a donation to my PayPal account. That's greatly appreciated, and I thank you very much for doing that. It helps me out and helps me to continue to make these videos. And now let's see what else. Oh yeah, I can't answer any questions that you present to me on my eBay channel eBay does not allow for interaction for general correspondence through their messaging system. So if you got a question about something I have for sale, I can answer that. But if it's a question about refining or anything related to refining or where to buy stuff and things like that, I won't be able to answer those questions. I'll just have to delete them. I left my email in the About page on my channel. Click on About, and right at the top there, I've got an email. So if you have questions, you can email me using that email. I check it every day, and I try to answer the questions the best that I can. And let's see, we had one more thing. What was it? Oh yeah, I don't refine other people's material. I've been getting a lot of requests. People have material that they want refined into pure gold or pure silver or whatever the case may be, and I just don't do that. I don't do any toll refining for other people. I only work on the stuff that my wife and I find at local yard sales and resale shops. So, okay, that'll do it. That'll conclude this video. Thanks for watching.